So I will talk about conditional generation with planning. I want to talk about like why planning is important in generative models that we are seeing at this point. I used to take a lot of time. I used to take a lot of time explaining this, like what was the task, why was this important, what were the challenges. But I think at this point, these problems are pretty obvious to everyone, actually, despite you have worked in generation or not worked in generation. But again, just for sake, I will repeat it anyway. So like we have seen how much improvement has happened in generative models, but still some of these problems are still very common. So like hallucinations. So for example, given context, it will generate something that is not consistent with the context. So here are some examples from summarization. So on the left, you have a BBC article, and then you have a summary, two possible summaries of that article. And at the top, you have a correct summary, but at the bottom, you have the span highlighted in red that is not consistent with the input. So, and this thing has like multiplied nowadays, like with generative models like large language, like ChatGPT or Palm, etc. And one thing that always bothered me, like even from T5 or neural generation models itself, is like there's a really lack of controllability or explainability from these generated text from these black box models. In real world scenarios, like these things have gotten much more complicated. So for example, the earlier example were from single document summarization, but now we are talking about simply interacting with generative models, asking for really long responses. Or you can think of like asking a very general query and try to assume that the model will be able to consolidate information from multiple documents in a very complex context and be able to generate something that is meaningful and consistent with the world or with the world knowledge and or with the context that has been given. So that brings kind of lots of additional complications, like you have to deal with like how to better represent long inputs, how to infer over the long context or complex context over like multiple set of documents, multiple set of facts, multiple set of modalities, and then be able to generate long form outputs that covers diverse aspects of the query or the user queries. So I have been like our group at Google have been focusing on how we can address some of these issues. So like how we can generate long form multifaceted response in a planned and controlled fashion and be able to generate more diverse output while respecting some of these criteria. So I will talk about some of our work in past couple of years. And the main reason that we thought that that's happening is due to the black box nature of generative models that we have. So either we talk about encoder-decoder model or we talk about decoder-only model. Most often the case is that we take some context, the input context, and then we start generating target or the output from scratch. And what we propose here is that instead of directly generating the output, let's introduce some intermediate structure. And that is what we call planning, to basically plan what the model needs to generate. And then generate the output that is fully grounded to that intermediate plan. So with grounding means here is not grounded to the world knowledge directly, but the output has to be grounded to that intermediate structure, that intermediate plan. And that makes this generation process more explainable and more controllable. So because now if you chose your intermediate plan in a better way, then you could control your intermediate structure, and that will lead to change in the output that is being generated by the model. So there has been several work from our group. So one is at a very early stage, we introduce, so let's say if you have a article and you want to generate a summary for that article. So we introduced the notion of planning using entity chains. So the idea was that instead of directly generating the summary, model must decide what is the sequence of entities that it needs to discuss in the output, and then follow that plan to generate that order of entities and the entities that have appeared in the plan to verbalize in the final output. I will not go too much into detail here. So as you can imagine, so like entities, we have shown like how it can be helpful in controllable generation or improving factuality of the output, but they were not very expressive. Expressive means it doesn't tell you much about why model has decided to choose those entities and given that particular article. So a better way is that I will focus in this talk is using question answer plans. So what I mean with this is, let's say if you have a question, what is the Titanic known for? So instead of directly generating a response to it, model has to decide what are the subtopics that it should cover. So in this case, what kind of ship was RMS Titanic? What was what line operated the RMS Titanic, and so on. And then it has to generate a response that tries to answer all these questions, set of questions collectively. And so this has a very interesting connection to question under discourse, discourse theory, where the idea is that, like when we also speak or when we try to write our ideas, we often think of what are the subtopics or sub-questions that needs to be addressed. There's another work using for long-form question answering, which also tries to leverage similar mechanism, which will appear at ACL. The idea is that, let's say, if you have a complex question or if you have an ambiguous question, similar kind of planning could help you to disambiguate the context of the original question that you have. So for example, if you have, where did the term shooting break come from? So instead of, like if you want to better generate that response that covers different aspects of the query itself, model must first learn to refine the original query itself by breaking down into subqueries, identifying why there is ambiguity in the question itself. So in this talk, I will focus on the question answering planning. And the idea is that, like how, given any question, how model could plan using a set of question answer plans. So as you can imagine, like this kind of information is often not in the training data, right? So like you often have, let's say if you talk about summarization task, you often have a document and you have the summary. If you have a question answering task, you often have question and response. So this is this kind of a planning step is often not given in the training set. So we need to have like how we can get these kind of planning information in the super to train our model itself. So what we do is we have a two-step training process. So one is we annotate our gold answers or our summaries with this kind of planning. So for example, if you have, let's say if you have a summarized question answering data set, and given a question, if we want to generate a response to this, as we have shown at the bottom, we want model to generate not just the target, but also the plan. So what we do is we basically, the first step focuses on the blueprint or the question answering annotation of that response itself. And once we have that the blueprint annotation, we can then train any model that basically takes the original query and the set of documents or the set of context, and then not only generate the response, but it must generate the blueprint or the question answer plans, and then generate a response that is grounded to that question answer plans. And what is benefit of doing this is during inference, we do not need any kind of extra annotation. Because once we have annotated this during training, during inference, all you need is the input query and the context, and then model will generate the blueprint and then the response that is grounded to it. So that way, as you can imagine, so like during inference, you do not add any additional complexity of annotating your training and annotating your test corpora. So I will go through slightly like how we get how we annotate any kind of reference set with these kind of blueprint annotations. So it follows like two major steps. One is like over generating set of questions given a text, and then we apply several filters to make the ideal blueprint that will cover all the information that we have in the reference. So for example, for the first step, we can further break it down into 4 major steps. So the first step will focus on over generating questions for all the answer spans that we observe in the reference. So as you can see in the first one, and for that one, in this particular work, we used a squad trained question generation model. And then we have applied 3 different filters to filter out like repeated questions or the questions that were not very interesting. So the second step, for example, focuses on are the questions that are being generated, they are correct or not? And we do this by a round trip consistency check, where we check that the question that we have generated from the reference is actually correctly answered in the text that we have. So for example, we have the answer span from which we are generating the question, but then we can use the text to answer that particular question and try to see if the answer matches or not. The third one is really interesting. So which is called Ream-based theory, which basically tells that we should have questions in our blueprint that focuses on new information of the text. And according to the Ream theory, the new information in text often appears at on the right part of the text, right part of the sentence. And using this simple heuristic, we can gradually select questions that focuses on answer spans that appear in the right part of the sentences. And finally, we apply coverage, which basically filters out, which uses lexical coverage to filter out questions that repeats information. So after doing this, we basically, given this any reference text, we annotate it with an ideal blueprint that covers important information that appears in this text and tries to cover all the information that we have that we observe in the text. We have experimented with like 3 different variants of blueprint models. So I will briefly go through like all 3 of them. So first one is end-to-end model. The second one is multitask, and third one is iterative. So the first one is end-to-end is where model has to generate the whole blueprint, and then it will generate the output that is completely grounded, to that, the complete blueprint of the text. So as you can imagine, so this is very helpful because the text is generated conditioned on the whole blueprint that model has decided, but it can be complex. It can be difficult if the text is very large. So for example, if text is very long, then blueprint could become long, and then model will face difficulty in generating longer sequences. So to address some of these issues, we proposed another one, which is called multitask. So where instead of generating the whole blueprint, we forced model to separate, divide blueprints into 2 subtasks. So one kind of focuses on, one task focuses on just generating answer spans and then generating the text. But as we are also interested in generating questions, another task focuses on answer spans followed by all the questions that appear in the blueprint. So that way, model is learning to generate the blueprint, but the text is not grounded to, not conditioned on the complete blueprint, but only the answer spans that appear in the text. So it is kind of similar to the entity chain, but more generalized version of entity chain that I briefly mentioned earlier. So this is, in this case, like model will have some notion of kind of what kind of answers I need to cover in the text without knowing kind of in what context those answer spans should be covered in the text. Finally, there's an iterative model, which is which is very interesting, is where instead of generating the whole text, you break down your text into chunks, and then you generate the whole blueprint for the chunk, and then you generate that chunk of the text, and then you followed by generating the next set of blueprints and the two following text, and so on. So one advantage with this is now each time you're generating text, it is conditioned on its blueprint and the text that has been generated so far. Okay, so I showed this example. So so in this work, we kind of focused on 3 different tasks depending on varying complexities. So one is query focus summarization, where given a query and a bunch of documents, we want to generate a long form response to that original query. So this is very related to like how Google search might work. So for example, like user may be asking question, and then you have a bunch of search results, and you want to generate a generative response to that original query. You could also imagine this could be highly relevant to large language model setup in like similar to what we observe in ChatGPT, etc. There's another very interesting academic setup is WikiCatSum, so which is the task of Wikipedia generation. Again, so this is very challenging in the way that you have to generate really long Wikipedia abstract, focusing on summarizing information from thousands of articles. So in this case, I think on average, there were hundreds of articles for each output passage from Wikipedia. This one is another very challenging task, is like summarizing episodes, like TV episodes. So for example, in this case, we have a whole Big Bang Theory episode, and we need to generate a long summary for that episode transcript. So here, this one kind of shows the complexity involved in different tasks. As you can see, so like in Aquamuse, we have around, on average, around 7 documents. But in WikiCatSum, we have around 135 passages per topic. And as you can imagine, so like the output in all these cases is very long. It's like on average, I think 5 to 7 sentences. So the idea is like main reason that we chose these tasks was because we wanted to show how blueprints can be helpful in planning and generating long form responses, which requires to cover like multifaceted nature of the original query or the topics. So I will briefly go over some of the results here. So here I show Ruse results comparing different blueprint models to T5 baseline, which is shown the leftmost column on for each task. So for example, we have long T5 baseline, and then we have end-to-end blueprint model, then we have multitask blueprint model, and then we have iterative blueprint model. So in general, what we observe is the blueprint model, we see slight drop in terms of Ruse scores, which is especially when summaries are not that long. So for example, in Aquamuse, which was long form QA, the summaries were slightly shorter than Wikipedia and the script summarization datasets. And when that is the case, then T5 or long T5, simple seq-to-seq models tend to learn to better generate reference style summaries. But that is not the case when you have really long output. When model has to generate long form outputs, these sequence to sequence models often hallucinates or go off topic and generate something that completely diverges from the topic that is discussed in the context. And in comparison, like there we see that the blueprint model has either better or like competitive to the seq-to-seq baseline that we have. But I wanted to, like, as we all know, like Ruse is, there is no like single reference to some of these tasks that I've just mentioned. So Ruse is not a very good measure to to evaluate the quality of what is being generated. But so I wanted to emphasize here, like how planning can be useful in terms of not just generating the output, but also for evaluations. So for example, in this case, because we have these plans, explicit plans in terms of telling why model is generating something, we can leverage that to better evaluate text itself. So for example, in this case, given that we have these plans from the model itself during prediction, we could use that to check if the model, how model is performing in terms of groundedness. So like how well model respects the plan that it has decided during the generation process. But we could, at the same time, we could also use the plan itself to directly assess how faithful the text is by checking if these questions are being correctly answered in the input itself, in the context itself, how well these questions are presented in the input. So focusing on groundedness, where we simply check if these questions are answered in the generated text, we started seeing the importance of these planning-based models. So again, of course, here we do not have seq-to-seq baseline because we do not have the generated plan. But what we observe here is we see, like, compared to, like, among 3 blueprint models, both end-to-end models and iterative models perform significantly better than multitask model. And that is because the text is generated conditioned on the whole blueprint compared to only focusing on answer chains that we have seen in multitasking setup. Okay, I just said this. And as I mentioned, so now you started seeing kind of when you compare the faithfulness of the generated output. So this one, in this case, we have chosen the best model, the iterative model from the earlier stage. And we compared it to the seq-to-seq long-T5 model. And then we started seeing gain in terms of faithfulness of the model that is of the text that is being generated from these models when it uses blueprint versus when it doesn't use blueprint. So in this case, the faithfulness is measured by common metric called entailment, which measures how well each sentence in the output is entailed by the input documents. Again, this is not perfect, but this is the best measure at this point we have. But one could imagine replacing this with, like, maybe a classifier trained on human annotation. So I wanted to show at this stage, I want to show, like, several, like, how blueprint models bring controllability in the generative process. And again, going back to, like, and that happens because of this grounded generation that comes inherently due to this planning stage in the model. So first stage is, like, this example shows how we can use this kind of planning-based approach to improve faithfulness. So for example, let's say model has generated a certain plan, and we know we could manually modify the plan itself, or we could let a automatic classifier tells that which question is answered correctly in the input or not. And we could use that classifier to modify the plan automatically. And then we could prompt our decoder with this modified plan and let model generate a new text. And that way we could improve the quality of the output text automatically. So here, for example, in this case, we found out that, okay, the answer is not correctly, for the 4th question, the answer is not correct. So we could replace it with the correct answer, and the 3rd question is simply incorrect. So we could simply drop out from the plan. And then we could generate a response that is faithful to the set of input documents. And this also gets reflected in both automatic and human eval that we see on the on left across all 3 tasks. There are lots of added benefits of bringing planning, this form of planning into the generative process. So for example, here, let's say if you, so at the top, what we see is what model is generating to a certain response. So as you can see, so you have a plan, and this is taken from iterative blueprint model. So we have a plan, and then model generates the text, and then we have another 2 questions, and then followed by a text, and so on. But let's say if we want to generate a response that is simpler, doesn't generate like longer text. So we can let model, we could automatically say that, okay, during iterative generation process, models should just focus on one proposition. So just focus on generating one question answer pairs, and then one question answer pair, and then generate a simple text based on that. And then we see by simply putting that constraint during inference process, model is generating a slightly different summary with a much simpler sentences compared to what we had before. Again, so here very similar to like how you could also not just focusing on the faithfulness, but you could also focus on like diverse set of intents. So here, like how you could prompt your model differently with a modified plan, and then model will generate a slightly different text. What is something very interesting I think I briefly mentioned is, so it's not only bringing controllability, but it also brings some notion of like explainability to the model, why something is happening, why model is generating a certain text. And that is, so this example shows that beautifully. So like when we took our Aquamuse model and simply queried kind of who directed Scarface. And if you know this film, even if you search Google, you will get a 1983 film, which is most popular. And we were expecting that model will automatically generate a reference to 1932 film, which is actually, so 1983 film is actually a remake of that 1932 film, which is much less popular. But we were not expecting that actually both of these films are based on a novel that was written in 1929. So this we found really interesting, because model, by using these question answer plans, model kind of gives you insight into like what are the ambiguities, what are the hidden dimensions that you need to reveal the model reasoning process itself, and how to then generate the text that is grounded or tries to summarize that reasoning process. So yeah, I think that's all for the main content. But just to summarize, I think like we need to really like investigate a lot more. I strongly believe in this kind of planning stage during generative process, because it brings lots of controllability and explainability. There's a very nice connection to chain of thought works. So like in chain of thought works, the way I say it, like this is very similar to chain of thought works. The one main difference is chain of thoughts are more natural way of revealing plans to models or forcing model to generate a reasoning process. But this is much more controllable in the way that you could leverage automated, you could leverage it to better evaluate your text, better control your text, or using automatic ways. Okay. If you want to take a look, want to know a bit more in some of these works, so please go and refer to some of these papers. There's a very nice demo. So if you follow this link, yeah, I think this slide will be shared afterwards. So yeah, you could follow this link and have a look at the demo. Yep, thank you so much.
Thank you very much, Shashi, for this very interesting talk. Do we have any questions from the audience or from the online audience? Anna?
Yes.
Yeah, I'm curious about the questions. I think it's a very nice tool, as you explained what it's going to do on. And maybe that explained that already. How do you decide on the granularity of questions, on the number of questions, and so on? Is that basically a hyperparameter that you could tune and adjust to your application, target application?
Can we repeat the question for the
yeah audience? So the question is like, how do we decide the granularity of the questions that we keep in the blueprint? could be depending on the task or depending on the domain. Can we choose a hyperparameter that allows you to like what kind of information we want to capture in the questions? That's a very good question. So like in this case, because we had to rely a lot on, like this was kind of like when we explored the potential of large language models. So we leveraged like a Squad and NQ datasets to train question generators. So of course it is then very much dependent on the kind of questions that we observe in a Squad and NQ. The Squad tends to be very fine-grained. NQ is a bit more natural, bit more diverse general questions. But I think, yeah, I totally agree. Like depending on the domain, that's not what we want. It might be much more natural to have, like, let's say if you want to plan the structure of the text, then you may want to have more hierarchical questions that, so we start with a more high-level question, and then we break it down into more fine-grained question, and then we go back to high-level question and so on. And I think now all of this is possible. Like you could, as we have seen that in like using large language models, you could simply have a few prompts or generate synthetic data and let model do this kind of the blueprint generation on the fly. And then you could adapt to your setup that you are actually looking for. Yeah.
Thank you. Any more questions?
So my question, so if I understand correctly, both conditions on the blueprint are also the input document, right?
Yeah.
And all the examples.
Yeah.
Is there, did you do anything, or does it make sense to actually just generate directly from the, because from some of the examples I was looking at, all the information that was necessary to generate the output was actually expressed in the blueprint. I wonder if that's even a feasible approach or something.
That was one of the baseline, yes.
Okay.
Yeah, but I think it's still to put everything in order. So like blueprint could be a set of questions, right? But to provide like the whole picture, how do you want to answer and bring them some order into the text? You need to have context, the input context. So so we had that baseline in the paper, and we found that to be relevant, important to have the context, the input context into generation, during the generation of the output.
Right. Much worse than one.
I mean, in terms of rows, like, yeah, there were a significant drop. Yeah. Yeah. Yeah.
I just wanted to ask you a little bit more about the relation between this method and the question under discussion framework.
Yeah.
I mean, I'm not super familiar with QUD, to be honest, but I mean, at the first glance, it just looks like the same.
Yeah.
So what are the difference?
I think the question under discussion is much richer than what we did in this work. So this work is very shallow way of making kind of some connection to QUD framework. But I think I think depending on the, again, going back to Anna's question, like depending on the task or the way the domain or the query itself, the question under discussion, the QED would look very different depending on the text we want to generate.
Right.
And that is not covered at all in this work, right? Like we just use the Squad and have very simple filters to optimize the blueprint in terms of more like focusing more on information coverage. But I think it will be really interesting to see now. Let's say if you want to generate a long form response that focuses on different aspects, very like comparison kind of aspects, or covering, let's say if you're talking about climate change, then presenting different opinions, or answering to a query that requires a list. So all these things will have very different QED.
Thank you. Opportunities for a last question?
Yeah.
So thanks for the talk. I was curious, you have these 3 data sets that you evaluate on. And I was assuming you train only on the data set itself, and you also evaluate it like an in-domain evaluation.
Yeah.
Do you think it will make any sense to try it cross domain, or are the tasks like defined too differently, or are maybe the sources too different, or?
I think it would make sense. So the setup we had, it didn't make much sense because we were using T5. But now I don't think, yeah, that's a good idea. So I think we might, yeah, it might be interesting to merge all of them and have a single model and try to evaluate on all different tasks.
Would it be feasible to go cross data as well, or would it just be too difficult?
I think we have tried in some of the recent experiments, like to do cross task experiments, and it doesn't, because the model is, especially it doesn't work when you're fine tuning on one data set, like over fine tuning. So it starts to overfit in terms of not just learning to generate blueprint, but also the format or a style of that domain itself. So for example, Aquamuse answers would look very different from Wikipedia abstract itself. So you will clearly see drop in performance because the model is very much kind of trained on, fine-tuned on generating Aquamuse's style responses. So I don't think it would make sense to have like do cross-domain experiments using these models. But I think, it would be interesting to try where model is more robust. Like if, for example, if you have instruction tuned model, then I don't think you will have that problem, and it would be very easy to adapt. Yeah.
Thank you.
Thank you very much, Shashi.
Thank you so much.
So please give us a couple of minutes to set up the stage for the next speaker.